The best known equation in all of science is Einstein's famous E equals mc squared. Stated simply, the equation says that energy, which is the E, equals mass, which is the m. The c squared term is just a conversion factor, like when you convert feet to meters. The understanding that mass and energy were the same was a revolutionary idea, but that's only part of the story. In 1928, physicist Paul Dirac realized that not only were energy and matter equivalent, but there existed another substance called antimatter. I've talked about antimatter in another video, which you can watch for more information. However, I'll give you the highlights here. Antimatter is basically the opposite of matter. If antimatter touches matter, the two substances completely annihilate one another and convert into energy. The converse is also true. Energy can convert into matter and antimatter, and this is a crucial point. When energy converts to matter, it also converts into antimatter at the same time. And not some random amount of antimatter. The amount of matter created and the amount of antimatter created are identical. This graphic drives the point home. Energy can turn into matter and antimatter, and the amount of matter and antimatter is equal. Keep that in mind as I redirect your attention to a long, long time ago, just fractions of a second after the Big Bang. The universe was full of a roiling maelstrom of energy, with energy converting into matter and antimatter and back again. This was the cauldron of creation, the very foundry in which the universe itself was forged. As the Big Bang unfolded, the universe expanded and cooled. And as it cooled, the energy dropped below the point at which it can convert into matter and antimatter. Because the universe expanded, the separation between matter and antimatter particles would grow. In the simplest scenario, that's it. The remaining matter and antimatter would wander around the cosmos, occasionally meeting and annihilating. As we peered into the sky, we'd expect to see a cooling cosmos with equal amounts of matter and antimatter, an occasional flash of energy signifying a chance meeting between these two antagonistic substances. Simple, right? There's only one problem. That's not what we see. Everywhere you look, you see only matter. I'm made of matter. You're made of matter. Everything we can see in our biggest telescopes is matter. There is simply no antimatter to be found. The prediction of equal amounts of matter and antimatter is completely falsified. When a theory is falsified this badly, something has to be changed. So what gives? Do we have to reject Einstein's famous equation? Is the idea of antimatter wrong? Do we need to discover another explanation? What do we know? Well, we know that E equals mc squared works. We have tested it countless times. We know that antimatter is made in identical quantities as matter. We clearly need a new idea. The mystery of the disappearing antimatter is a big question for modern physics. Several experiments in the recent past and the near future have studied and will continue to study this question. This is an obvious hole in our understanding of the universe, and as questions go, it's a biggie. I don't know what the answer will be, but what I do know is that scientists are doggedly following every clue, hoping to solve this difficult mystery.